Hello? Hello? Can you hear that? Okay. Okay, so let's go and let's start again then. Sorry for the trouble. Then let's switch to the presentation, and I'm going to get to the point straight then. This is a webinar that is made by Deconstruct. It's a company that has built a ROS Development Studio. And we are going to talk today about how to develop for ROS, for programs, to create programs for robots that use ROS in a fast way. My name is Ricardo Tellez, and I am the CEO of Deconstruct. That is the company that has built the ROS Development Studio. And those are the things that we are going to talk today. It's about how to build a ROS program using the ROS Development Studio. How you can test your programs with a set of robots that are already provided by the ROS Development Studio. I will also show how you can test that with your own robot, in case you have it, and how to share this program that you have created here and test it with other people, so you can share with others and they can work on the same thing that you are working on, the same packages. Finally, we'll go to the questions. Okay, so let's start. The ROS Development Studio. This is a program, a web platform that we have developed in order to allow people to develop fast and in an easy way for ROS. And just would like to tell you that if you wait until the end, I will give you some instructions about how to receive a PDF containing all the step-by-step instructions that we are watching here in this webinar, but you can have a PDF that contains the text describing and the pictures. So I will give you the details by the end of the webinar. Then let's go. How to build a ROS program using the ROS Development Studio, of course. Then let me switch to the web browser. In this case, is here. So this is my browser. This is Chrome. You can use Chrome or Firefox. And I have already logged in into the ROS Development Studio. In order to access, very easy, rds.deconstructsim.com. That's it. Then you will get to some page like this. After you create an account, a free account, you can check that information by yourself. Great. Then here we provide some projects that are already working, but the interesting thing is that we built our own project. Then let's create our own project here, create a new project, and let's call it my project, for example. It's a private one because it's something for me, and this is a description. So this is a demo from the webinar. Okay, so I create that, has been created, and then it has been added to my list of private projects. You see here there is a switch where I can switch between the public ones. Those are projects provided by other people. And then this is the public one, the private one, my projects. And here it is, the one that I have created. So let's open it. Open the project. Run. Now it is opening the ROS Development Studio environment. And it is the place where we are going to build the ROS application. Okay, and what we are going to do is to create a package for combining odometry with IMU data. Okay, so that's a program that we would like to create, for example. Then in this case, let me just close this thing here because I'm going to tell that here. The first thing that we can see here is the IDE. I can change the view of all of this by clicking here. And here we have the IDE, and it contains two parts, the one with the files of the Catkin workspace that has been selected, the different Catkin workspace that we have available, and here is the editor. So in this case, I have the Catkin workspace with a source, of course, directory, and a simulation gazebo package that is created by default that you can use for wherever you want. So in this case, I don't want it, so I'm going to delete. Just delete. That's it. Gone. We don't want it. So what I want to is to create my own package. So I'm going to use here the terminal that is here in order to create my package. So I'm going to go to that Catkin workspace here, workspace, and then inside the source. Now I am inside this directory that contains nothing at present. Okay, so I am here. Now I'm going to create my package. Create package. Let's say, for example, my package. That depends on ROS-Pi. Let's do it simple. Okay. So now it has been created, and if I come here, I can see my package has been created with an empty source, CMake, etc. Now I'm going to create, contain the config file. So it's a config directory that contains config file for this package that combines odometry with IMU. And I'm going to create another folder for a launch file that will launch everything. Great. Then let's create here the config file inside this package. Let me create a new file. New file. Then it's going to call AKF config, and it's of type YAM. And then inside the launch file, let's create a new file that we will call start.launch. Great. So far, so good. Then we are going to fill with information those files in order to launch the system that will combine the odometry with the IMU data. And for that, I'm going to just open another program. So I have it here. Sorry, I have to search for it. Just wait a second. So I'm looking for this information and putting it here on the files. And here it is. So I'm going to share the screen with you. So I have copied, what I have done is to copy the content that has to be put into those files, and I have set them up here. Okay, so I have, let me just enlarge this environment. I'm going to enlarge it. And here is the content that is required to be put into the launch file that will launch the robot localization node. And that is looking into my package for the config file that is called AKF localization. Okay, so we have to change this for AKF config. That is the name that I have put here. Okay. Then here in the AKF config YAM, I have put it all, just the configuration required for that node, for the robot localization node to work properly. Okay, so I have created already my package that can launch this program. Okay, so this, whenever we launch this launch file, the start launch file, it will launch from a package that is called robot localization. It will execute this AKF localization node. Okay, so far, imagine that this is a more complicated ROS program, but this is just for an example for today. Great. So now I have created my package and my code. I have everything. I can compile it. So I can come here and compile it. For that, I have to get down into another directory and then do the cat key make. Great. So it's compiling. Now, while it is compiling, I have to test this with a robot, because otherwise I don't know how this program is working or not, then that's the place where we are going to select a robot from the ones that are here provided. And I need a robot that contains odometry and IMU. For example, let's use this one, the Summit XL by Robotics. So I'm going to press here, and then the simulation of the Summit will start in a few seconds. Of course, we can change the configuration of this environment at any time by clicking here. So I'm going to put the simulation in the middle while it is loading. And well, whenever you have a look at that, you will see. Here it is. So we have the simulation of the robot here in a certain environment, okay? So yeah, whoops, is the wall there? So let me get it out. Here it is. Okay, so this is the whole environment. Great, and we have the robot here that is running. Now, let's do one thing. I have created my package here. I have uploaded a simulation that I'm going to test with it. And now I'm going to launch my package. So in order to launch my package, the only thing that I have to do is to come here and do a ROS launch of my package and the start launch. Okay. So now my software, the package, the ROS package that I have created here is just a configuration file, etc. But it's running now, and it's been applied to that robot. In this case, it's a program that fuses information from odometry and IMU. So here I have configured the topic of the odometry, and here the IMU data. Great. So yeah, but how can I see if this is working or not? Okay, so at any point in time, what you can do is to launch another shell and do your experiments in the same way as you would do in a desktop computer, but using only the shell. For example, you can do a ROS node list and check what is happening. Let's see if our one is running, and it's this one here. So it is running ours. Great. But I would like to see something more. Great, no problem. Let's run the Rviz and check. Let's check if this is working. Okay, so I have launched Rviz here, but the visual screen cannot appear here, of course, because it's just a website. Then the thing that I have to do in order to open graphical tool is to come to the main window and press this button here, Open ROS Graphical Tools. So this is going to pop up a new tab in your web browser, and here we have, and I don't know why it's appearing like two Rvizes there. I don't know what is happening there. So maybe it's a demo effect. And let's just put this on top of the window. Great. Now let's show, for example, the robot here. Let's add the robot. Let's see if everything is published properly. Robot. Oh, what is happening? I see white. Yes. Why is that? Because the transform from map is not correct. Yes. From left wheel to map. Why? Because the fixed frame is a map, and there is nobody publishing a map. But we have many other frames that we can publish. I'm interested in the odometry. So I'm going to select odometry. Here we have everything in green. Great. Now I'm interested on watching what the laser is doing. So I'm going to add the laser. Let me see, laser scan, and select the topic of the robot that is publishing the laser. Great. So now we can see what the robot is watching on the sides. You see, those sides of the robot there. Let me put it bigger. Yes, on those sides. Great. Now, but what I'm interested is to see if the odometry is being published by the program that has to fuse the two informations. So I'm going to add an odometry visualization here. Here it is, and I'm going to configure to show the odometry being published, not by the odometry itself, but by the odometry filtered. The odometry filtered is the output of my program. And here it is, so it has been published. Great. So in the same way, you could use this to debug in case that it doesn't work or else. So what is next? So I have shown you all that. Then, for example, we can move the robot. Let's move the robot and see if this odometry is modified and if the lasers are watching something different. Great. For that, I will need another shell because all the others are already occupied. And I'm going to launch the program that moves the robot. And that's one is the ROS. Let me check. ROS launches the Summit Excel tools. Start the layout. Launch. And I have a problem here that is not being found. Let me see. For some reason, it's not being found. Okay. Let me check. Quick check. If not, we'll move to something different. So maybe it's not on the ROS package path, that program. But okay, I checked before and everything was working. So I don't know. Due to the press of the time, let's move to the next thing. But we can move the robot in using the teleop, normal teleop, and then see how the odometry will be changing and also the laser will be changing. Okay, so now up to here, we have seen how to test that with this robot here. But we could also test it with a different robot. Imagine that I want to use the same thing, the same program with a different robot. Okay, so I'm going to close this program. And I'm going to launch a different robot. Let's select another one. For example, the Jackal. I know the Jackal contains IMU and ODOM. So I'm going to launch it. Just press it there, and I will do the same exact thing. So everything is already set up. So I only wait for the simulation to appear, and then I will just launch my program against that robot there. It's loading. Loading. And here it comes. Great. Here comes the Jackal robot. Then I'm going to launch my program. In reality, I should check if the topics do contain the same topics with the same names. And of course, I have the odometry here and the IMU. It's around there. IMU data, it's there. So I can launch also my package and use it in the same sense for that other robot. And in the same way, I could test in different robots, different environments. There, and I'm changing the simulations like this. No, but this is even better, that I can also use the simulation of another robot that doesn't exist here. Imagine that you want to test with your own robot or another robot that doesn't exist here. So that is the case that we are going to do right now, and is the case that we are going to, let me change this, something more convenient here. So let me show you that we are going to use the Turtlebot 3 simulation. So what we are going to do is to download this simulation from the kit, then compile it, and then launch it. And we can use our program and test it on that. So how is that done? Very easy. Now, we are at the Catkin workspace. This is the workspace where we are putting all our programs. But in order to use a different simulation, we have to use the simulation workspace. If I select that one, you can see here inside the source, there is nothing. So let's go to that workspace that is here, simulation workspace, source. Here, there is nothing, the CMake list. Now let's clone the Tartarbox 3 simulation that I have prepared here. So in order to clone it, you have to do git clone of this. So let's do a git clone here. Done. And the thing is that the Tartarbox 3 requires two more git to be used. So let's click here and get the other two clones that we have to do. One for the messages, and another one for the Tartarbox 3 packages. Great. So I'm cloning the 3 repos here. And now, once I have them, I'm going to compile them. Then I'm going to launch them. And then I would be able to test my program on that robot. Okay, the Tartarbox 3 is a little bit longer because it contains a lot of packages. Great, it's almost there. Great. Then I'm going to start a compilation. So I have to download one directory and then do the cat key make. Here we go. Okay, so now this is going to take a while. So in the meantime that this is compiling, because it contains a lot of packages, let me talk about the IPython notebook that we have here. The IPython notebook is a utility that is very, very useful in the case that you want to distribute all the things that you are developing here. Imagine that you are creating some packages, some programs here in your Calculus workspace that you want to share with some other people, maybe people of your team, maybe doing a demo for your clients or whatever. You want that to include a simulation. So you will include something here in your simulation workspace. You will include here your simulation. And then you also would like to contain a kind of book that shows how to use everything and how everything works. Okay, that's the purpose of the notebook workspace. And the notebook workspace contains those cells here that you can read, but also you can execute at any point in time, provided that it contains Python commands. For example, in this case, I have a Python command that sets a to 1 + 1 and then prints a. If I execute this cell, okay, but you can do things more important like this. For example, I can interact with the current simulation. So I am selecting this cell here, and then I press this. So what I get is a print hello from my Python, but then print the current ROS distro and the ROS version. So far, so good. But you can do even more. For example, you can read from the simulation, from the robot topic, and then do whatever you want with that. For example, let's do something, an example. So I'm coming here to the bottom and creating a new cell. And here I'm going to write a code for printing the odometry here. So how I'm going to do, the first thing is I'm going to import transpire because I'm going to do it in Python. Then the second thing that I'm going to do is to initialize my node. Let me put it bigger here. Yes, initialize my node, and let's call my node. That I'm going to create a subscriber. Transpire does subscriber. Very simple and very quick. It's going to be finished very quick. So the odometry topic, then the odometry message, and then the callback, my callback. Okay, we have it, everything. Now I have to create a callback. I have to import first from navigation messages. I have to import the odometry message. Import odometry. And now from. And now I'm going to create my callback. So my callback receives the message of odometry. In this case, I'm going to do is to print the message. But because this message is being printed by 30 times per second, I'm going to check that only prints one. So I'm going to create here very simple variable. I'm going to call it x. So this global x, I'm going to use it here. If x equals 0, then let's print it. And let's increment x. Okay, so now I have everything. No, because I have to do a spin here in order to get the program spinning. Okay, so here I have my code of Python that is interacting with this simulation running here. It's subscribing to this odometry topic and then printing the result. So let's do it. I have selected and I press play to print it. And it should appear here. Okay, so it's running, but it should appear here, the solution. Let me see. My callback, something missing, some error here. My subscriber, no. So wait. Kernel here, and let's execute again. I think it's correct. For ROS, yes. So it's only like this, and then pressing here, but it looks like it's not. It's just stayed here for whatever the reason. Then I cannot see why, because it should show here something. Okay, so it should appear here, the command of the message. I don't know. Space bin. So I think it's correct. I don't see any error here. Why is not showing? Let me check. Okay, so I don't know. Let me copy this and let's see if this has been executed correctly. Yes, yes. Yes, no problem. Okay, okay. Here, let's restart the kernel. And it looked like it's not restarting for some reason. Let me execute it here again. I'm going to try again. And no, for some reason it's not working, but the program is correct. Let me check it bigger. I cannot see the error. Stop it and restart the cell. Yeah, it looks like it's stuck because this is not changing from a start. Okay, let's do a refresh. Here I'm refreshing the whole environment and see if I can get this back. Okay, here it is. So I'm going to execute it again. And no, for whatever the reason, it doesn't work. So I will have to have a deeper look into this later. So the thing is that you can access with this into the odometry message. Let me just check that the topic odom is not there, maybe. I remember that it's called odom. Yes, it's here. And the ROS topic echo -1 odom. Ah, okay, so here it is. For some reason, the odometry is not being published in this robot. And maybe the reason is that it's the odometry filtered. Oh, okay. Okay, so let's do one thing because we have already installed the Turtlebot 3 simulation. That is the reason why it's not being published here, because nothing is being published in the odometry. Okay, so let's start anyway this simulation of the Turtlebot. Here I have installed the Turtlebot simulation and I have compiled. Then once I have a simulation here that has been compiled, then I can launch it. And the Turtlebot 3 simulation contains a specific thing that is a parameter that you need to provide in order to decide which type of Turtlebot 3 you want to. And that's what I'm going to edit right now. So I have here the empty wall Turtlebot 3. Let me put it bigger. And in this simulation, you have to specify here the environment Turtlebot 3 model. I'm going to specify here the type burger, for example. That's it. So this is the Turtlebot 3 empty wall launch. That is the launch that I want to launch to generate the simulation here of the Turtlebot 3. And how do I do that? It's quite simple. You press this button here, and by pressing this button will go to the simulations workspace, look for all the launch files that exist in any of the packages stored there, and then tells you which one do you want to launch. So if you press here, then it's suggesting that one, but it's not the one that I want to launch. It's the Turtlebot. So I'm going to select this one. That is the one that I have modified, and then run. And now, after a few seconds, the robot will appear there. And once here you can see the messages of the simulation while it is loading. So in case that you have an error in the simulation, you can check here what is the error. There are some warnings also. And here it is, there was no error. And here we have the Turtlebot 3 simulation downloaded from the original repo from here. This is the official repository of Turtlebot 3 of Robotics company. So I have downloaded, I have it compiled, and I have launched it. You have seen how simple it was. Now I can do the test of the odometry, maybe. Let me see ROS topic list. What's the name of the odometry? It's called Odom. And let me check that it's publishing. Okay, great, it's publishing. So now I can execute this. Let me just refresh everything and restart the kernel. Great, so now I'm going to execute this code. And you will see it will communicate with Turtlebot and publish. Okay, here it is, the odometry. Great. So you can see how the Python notebook interacts with the actual simulation. And this is very powerful because you can use this as a live book. It's a book that is obtaining information and modifying itself in the same way. So, okay, so far so good. So I have the simulation here, and in the same way as I did with the other ones, I can launch now my program. That would be ROS launch, my package, start launch. And then this one will be tested and will be executed against this robot here. And we can go to the, of course, to the, where was it? Here is the robot model has changed. Well, actually, we should see if everything is still working for this. This scanner is not possible. So maybe this link. Okay, anyway, we should check now. Wow, there is a lot of here error messages here with Rviz. So we should debug now for this simulation of the Turtlebot if everything is correct or we have any issue there with the frames or with the different models, if the model is publishing everything. So here we see only base footprint. that doesn't look very good because it requires a lot more frames. But in any case, let me see. Let me check just if this is possible. Okay, no, the robot model still contains some errors. So it should be debugged here. What is the problem with the base footprint, etc., etc. But so this is basically the demonstration of how you can test your program with different robots, ones that are already provided with the RDS and some of them that are not. You can just use it with your downloading from a Git. All the information that you put here in this workspace will be synchronized with the Git. If you do modifications in the packages here, you can, of course, commit them to the Git. It is that status. Yes. So on branch master, so everything that you store here will be synchronized with the Git. So you can use it for working with another Git, that is a Git of your company or your team or whatever. Anything. Anyway, when you are finished, remember to save your current simulation project, actually, and then you will have everything accessible from this page. We are going to see when it's finished saving. And here. So now what we are going to see is we are about to finish, and I'm going to show you how you can share the whole thing that you have done here with anybody else. So you have created here several things. You have created here those simulations. So you have stored simulations in the Catkin workspace. In the simulation workspace, you have built those simulations. Then on the Catkin workspace, you have created your package. Notebook workspace, you have created your notebooks with this information here. So imagine that you want to share this with all your students or your client or your colleagues around there, so they don't have to start from the beginning doing all the things that I have been doing here. That is very simple. Because I have saved it as my project name, then I will go to my project, actually. And my project is here. So you just press the button here to share, and then you provide here a username of your colleague, of your students, of whoever. You have to provide the username of somebody else in the RDS that has an account in the RDS. So I'm going to share this with my colleague, Miguel. Then I'm going to share. And that's it. Everything has been shared. Now, my colleague Miguel has of all the things that I have done in the project. He has a full copy of that, and he can start working with this. So basically, that is all what I wanted to share with you. So I would like to finish now the webinar. Then in case that you want to receive a PDF containing the information that I have explained here, but step by step on a PDF, send me an email with this subject. I want to program ROS fast, and send me an email to my email address that is being shown there. That every Wednesday we have a ROS mastering live show on YouTube, on our channel here, where we are solving problems that people have by using ROS. Real life problems. It's not academic problems like how can I do a publisher subscriber. No, real life, like my robot doesn't read this, how can I do that with my robot that is equipped with a rotating laser or whatever. In case that you want to ask any question for the live show, visit this page here and submit your question. So that is all. Now I will answer any question that you may have at the chat. You can write it there, and I will try to answer the best that I can. Just be reminded that the voice is going a little bit slower than the chat. So there is a small delay between what you are hearing and what you are writing there. So I'm waiting for your questions. Any questions there? No questions? Let's see if somebody has a question. Nobody? Just to let you know that in case that you want to download your packages, for example, your project, it again, well, I don't need to relaunch because it's already launched. So I'm going to just open it. And here you have your, in the Catkin workspace, I have created my package. Then imagine that I want to download this and install on the real robot. So for this, it's very simple. Just click there, download. And by pressing this, I will receive a targz package file containing the packages that I have created. In that case, it's only one, but I can compress everything there and include all my packages. The same can be done with the simulations. So you see here, I have a bunch of different packages. I can then say that I want to download the whole source directory. Then you press here, and then it will download. Any questions? No questions? Any questions on the chat? Okay, here it appears, the target set. So I can download to my downloads directory. And there it goes. So I have the packages. Remember that the packages that I am downloading are exactly the same that I have tested. It means that if you have tested with the simulation, your code here, if it is working with the simulation, then it should work also in the real life. Well, it depends on the adaptation, of course, but you have good chances. And the packages here should be created in such a way that they can take the differences that may appear between the simulation and the real life. So it's your work to make this package robust enough and then test it in different environments. Any questions? No questions? Okay, I cannot see any question there on the chat, so we are going to finish here today. And thank you very much. If you have any question, you can, of course, send it to my email, to the same address here for the receiving the PDF. So I'll be happy to answer through email your questions and hope to see you here again soon. Remember, on Wednesday, there is the other webinar. Your attendance. Cheers.